Welcome to IDA's video channel. In this video, I will explain a little bit more about the settings for the analysis when you run the analysis in a IDA's Pipe Manager or Manage and Analyze. Before we open Pipe Manager or Manage and Analyze, let's open EPANET Help file because as you know from some previous exercises, IDAS uses EPANET engine for the analysis. So the settings that you see in IDAS are coming from the EPANET engine. You can either go to Compact Ribbon IDAS, Resources, and you can go to Support folder, or if you prefer using Extended Ribbon, go to IDAS Help, Support. Then go to Help, Reference Documents, and here is a EPANET 2 manual. Let me drag it over. So this is a PDF where you can find a little bit more about the various settings and options that you can find in IDAS. And we will look at some of the chapters in this manual. Let me drag it away and let's go to IDAS and let's open the Manage and Analyze or Pipe Manager in a compact ribbon. Go to Hydraulic Parameters. We ran the analysis in some previous exercises and the only settings that we went through was head loss formula. As you know, you can either choose Sharzy-Manning, Darcy-Weisbach or Hazen-Williams. Then there is a specific gravity. What does it mean? If you don't know what it means, you can always go to EPANET manual. You can go to Search, Specific Gravity, and let's see if we find a solution. And here is a chapter that describes hydraulic options. And here is the specific gravity more in detail. You can also find something like relative viscosity that is right here. If you don't know what this parameter means, you can always go to EPANET manual, but I will show you those that I use more often than others. For example, maximum trials, the default settings is 200. What does it mean? Let's go to Report, Analysis Report, and let's change the status report to full. Then run the analysis. What it does, it runs the analysis, but it gives you the full report, status report. And here you can see trial 1, relative flow change 0.85, trial 2, relative flow change 0.000001, which means this value is bigger than set accuracy and it happened within the 200 trials. If this value was bigger than accuracy and if I reached the number of maximum trials 200, it would stop. And then I would need to find out what's the problem. And in some cases, the network doesn't converge to a solution within 200 trials with a defined accuracy. In those cases, I need to raise or decrease the accuracy a bit, but be careful with that. And what I do, I check these numbers and those numbers generally are lower and lower and lower, and then they don't go below a specific level. So my accuracy must be a little bit above. But again, if the accuracy is too bad, then you need to check whether you modeled your network correctly. And let's go to Status Report. I already changed it to full because I wanted to see the trials. If you use yes, it doesn't show the trials if I analyze. It just shows you that it was balanced and that's done. And if I select the option none and if I run the analysis, it doesn't show anything. It just shows you the results for each and every hour. Now let's go to time and energy. Here you can specify the analysis start time, report start time, and analysis end time. Most of the time we run the analysis for 24 hours, but you can run it for a shorter period. If you run the water tank sizing, you need to run it for a longer period. But you can change the values here. You can also check the time steps. Most of the time we use a 1 hour hydraulic time step, for the quality 5 minutes, and for the reporting 1 hour. So here you can see the results every hour, as you can see. So you can change that as well. Clock start time at midnight and then the statistics. And this is a very useful drop-down because you can specify whether you want to have the results every hour, or you can specify you want to have maximums. And if you run the analyze, you can see here it shows the maximum node result, so you get a maximums. Or you can go to minimum, and again you can run the analysis and you get a minimums. In this case, there won't be such a big change, simply because our tank is quite big and there are no big changes in a network. But in some cases, there's a significant difference between the maximum and minimum. We can also try to change the tank size. In this case, I made it very big, but what if I make it much smaller, let's say 10 meters in diameter? And if I run the analysis, let me analyze. Okay, I go to report. And as you can see from the time 316, the flow control valve cannot deliver flow. Why? Because the tank is probably full and it cannot deliver anything else. And here the maximum and minimum will differ. If I go to maximum now, I believe the value will change. Let me analyze here. Okay. And the values are definitely higher. You can also use the average, none, or range. So if you want to see the results for each and every hour, you can analyze and you can see the results for every hour. And if you want, you can go back to hydraulic parameters and display full report, and let's analyze. And here you can see a little bit more trials as it tries to find a solution that it cannot deliver. You see here it says tank is closed at 4 meters because it is full. Let's go back to time and energy. So we covered some settings here. Regarding the energy options, I would suggest reading the EPANET manual. Let's go to analysis part. I already mentioned in some of the previous videos was the difference between the analyze and analyze peak flow. The difference is that the peak flow is more used for water reticulation networks, where you need to run the analysis, where you have no demand, then only house connections, and then house connections with fire hydrant 1, house connections with fire hydrant 2, and so on. And for that, we use patterns. But to develop those patterns is time consuming. So that's why this command, peak flow analysis, will automatically create those patterns for you, and it will assign them to your structures. But in this case, we use a normal analyze command. These buttons will take you to the library. And then we have a minimum velocity and maximum velocity. This is used for the conduits to show you the exclamation marks if there is a problem. For example, let me change the maximum velocity to 2.0. And as soon as I do that, it shows you the exclamation mark that the velocity is above that specified value. So this is just for your check. Or other way around, if the velocity was smaller than 0.7, again, you would see exclamation mark. If I change it back to 2.5, it doesn't remove those exclamation marks. If I select all of them, it refreshes this view. And then there is an analysis time result. For example, for the pipes, I can display the maximums, or I can display the results at the specific time. As you can see here, at a time 1, time 2, time 3, and so on. There is no change here, because in our case, the flow is constant. But if I go to structures, nodes, pressure, I might see some changes if I go down, as you can see. By the way, I can click here and use an arrow up or down, and it changes the values, as you can see. This is the change where tank gets full, so that's why there's a significant change in the number values. And this is briefly about the analysis settings, but as I said, if there's something you don't understand, I always suggest go through the EPANET Help file, because that describes all those properties more in detail. And as you know, when you run the analysis in IDAS Pipe Manager, it always creates INP file that can be used to import the network to EPANET or any other software that supports INP files.